Second topic is TE waves in rectangular waveguides. Identify the difference between TE and TM modes. So then TE waves, E field is transverse to the direction of wave propagation. H field only present in the direction of wave propagation. And TE waves is also called as H waves. HZ, HX and EY fields exist. EZ, EX and HY fields is 0. In TM waves, H field is transverse to the direction of wave propagation. E field only present in the direction of wave propagation. It is also called as E waves. In TM waves, E, Z, EX and H fields are exist, where HZ, HX and EY fields are 0. By product solution method, Hz equal to xy, where x is a function of x alone and y is a function of y alone. Inserted in wave equation for Hz and the solution was found, that is Hz equal to c1 cos bx plus c2 sin bx, c3 cos ay plus c4 sin ay. The boundary conditions are Ey equal to Ez equal to 0 at x equal to a and x equal to 0, and Ex equal to Ez equal to 0 at y equal to 0 and y equal to b. The basic field equations are Ex equal to minus j omega mu by h square dou hz by dou y, Ey equal to j omega mu by h square dou hz by dou x, hx equal to minus gamma by h square dou hz by dou x, and hy equal to minus gamma h square dou hz by dou y. We are taking Ex equal to minus j omega mu by h square dou hz by dou y and substituting the values of hz, we are getting Ex equal to minus j omega mu by h square into c1 cos bx plus c2 sin bx into minus c3 sin by plus c4 cos ay. Substituting the boundary condition 1, that is Ex equal to 0 at y equal to 0, we get c4 equal to 0. Therefore Hz becomes Hz equal to c1 cos bx plus c2 sin bx into c3 cos ay. Substituting the boundary condition 2, Ey equal to 0 at x equal to 0, we get Ey equal to j omega mu by h square dou by dou x of minus c1 b sin bx plus c2 b cos bx into c3 cos ay. Activity: at x equal to 0, Ey becomes j omega mu by h square into c2b c3 cos ay. To satisfy the boundary condition, either c2 or c3 in the above equation is 0, but c3 is not equal to 0 to make the field vanish. So instead, by putting c3 equal to 0, we are going to make c2 is equal to 0. The Hz equation becomes Hz equal to c cos bx cos ay e power minus gamma z. Similarly, the other field values Ex, Ey are calculated in TE waves in rectangular waveguide analysis. Hx and Hy values are calculated. By substituting gamma equal to j beta, where a equal to m pi by a, b equal to n pi by b, the fields Hz, Hx, Ex, Hy and Ey are calculated as shown in this slide. Assessment: thank you.